Okay, we don't just want to run tutorials, we want to dive into some natural resource work with Python. So here in tutorial 1.3.3, we're going to actually look at determining the area and land use adjacent to a river. This is a common problem, especially here in the Pacific Northwest, where folks cut too much timber too close to river or stream, and then it rains, that'll wash dirt, silt into a river, and that'll clog the gravel beds that are so important for salmon production. So here we've got some code to go ahead and select the Eel River from a river layer, and then also to pull out the TPZ zones for Humboldt County. Now, if I go ahead and run this, you're going to get an error because I haven't loaded the river layer yet. So that'll happen with these tutorials because we start giving you less information with subsequent tutorials when we've already covered it before. So I'm just going to go back to a previous tutorial, copy and paste our code for loading in the zoning layer, and then I'm going to go ahead and just copy and paste this code to load, and I need to then have a river layer. So this is going to be my river layer, and of course into that I want to be loading the river shape file, so I need to change the path to the file. Okay, now when I go ahead and run that, I should be able to get my Eel River and my TPZ files. And I'm going to go ahead and pause the video for a bit, so it'll take a little bit longer when you run. And we're back. And I went ahead and wrote these out to files because I wanted to go ahead into the SpaPyTest temp folder. That's where all of our output is going. Notice up here we've got an output folder path, SpaPyTest. So that's going, or SpaPyTest temp, sorry. So that's where everything's going. So here's our Eel River file, and I'm just going to drag and drop that into ARC. Yep, there's the Eel River. Yay! And let's see about our TPZ zones. Yep, looks like those are labeled with TPZ. All right, so everything's working. Now, this is one of the ways you can check your progress, and I do this sometimes. Make sure you remove the files from ArcGIS, otherwise it'll keep you from rewriting them. In fact, sometimes just removing them isn't enough. Sometimes you got to do project new, or even exit and re-enter ARC, and that's one of the reasons that I actually created this show, because that's a little bit faster and easier to use. But sometimes you got to put it in ARC so we can make sure that it's in the right area. Both are important. Okay, now let's move on. So back into this tutorial, and we're going to go ahead and create a buffer around the Eel River. Okay, and we're going to do that to 150 meters. All this data was originally in State Plane, but we reprojected it into UTM Zone 10 North, so it's all in meters. We'll show you in a future tutorial how you can use Python to project files. And the next step, while that's running, I'm going to go ahead and grab the next piece of code, which is where we're going to union these together. And I'll show you why we're doing both of these in just a second. Okay, so let's go ahead and run those. And we're back. All right, if we go into our folder again, you can see that we've got our river buffer. And let's load that up into ArcGIS. And if you zoom in, what you'll see is that when you run a buffer, it actually buffers each individual stream reach. So it's doing every single little stream reach, which is really not what we want, right? This is far too complicated. So that's why we want to do that union and union all those features together. And then we get a river buffer union, which is much nicer to work with, right? It's just one polygon that includes 150 meters on either side of the Eel River. Now I'm removing these, and also I'm going to go ahead and remove these from here, clean out my temp folder, which you want to do periodically so that you can see which files you're producing. Also, if we use data sets like we're doing here, we don't actually have to save them out all the time. You only have to do that when you need to, right? So you don't have to have a whole bunch of stuff in your folder. I'm going to leave extra stuff saved out for now, just so I can always go look at it. And now what we want to do is we want to go ahead and find the intersection of our buffer and our zoning data set. So we want to take our TPZ data and find the intersection of that and our buffered union of the river, or really find those properties that are within 150 meters of the river and then put that in here. Now, one of the problems is we found out with the zoning data set is it has some topological errors or spatial data errors in it. And the open source data set, open source libraries are very picky about their spatial data. ArcGIS is not, Blue Spray isn't, QGIS isn't that picky, but the open source libraries are very picky. So you'll get an error if you run an intersection with the zoning data set. This is a little trick you can use if you get that error, okay, where you can just do a buffer on a data set at a distance of 0, and that will actually clean up any errors. So let's go ahead and run that and see how it works. And we're back. Let's go ahead and take a look at our intersections. And now you can see, especially if we put in our river buffer and our TPZ zones, and then we zoom in, you can see that what we've done is we found all these little sections of river, okay, that are within our buffer and are part of something that's labeled as TPZ. So now we have all these little segments that are next to the river and part of a TPZ zone. Okay, so next step, we can go ahead and find the area of that. And of course, you could do all kinds of things, right? You could, this has parcel numbers for it that you could use to actually contact the owners of the property if needed. And this is going to compute the area. So here again, we go to the intersection data set. We're going to loop through it, and then we're going to get the geometry. Now, remember that we can't just access the attribute because the attribute hasn't been updated. So we've done an intersection. We've created new spatial data. If we use the attributes there before, that'll be for the whole TPZ. So we could update the attributes in ArcGIS, but it's easier in Python. We can just get the geometry for this feature. Okay, that gives us back the area, and then we can do area dot area, and that returns the area. It's in meters because that's the projection we're in. We can add those up, and then there's the amount of area. And of course, we could do all kinds of things with this. We could find different sizes of areas, ones that are over a certain amount, under a certain amount. We could do different buffer distances to find out areas that are really close to the river or further away. All kinds of things we could do.